Okay, so here we have two cubes, and they're separated by a distance across from each other. Let's first render this to see what this looks like normally. I have the edge width like this. You can see how the edge is really thick on the far cube. We don't want that. So in order to remedy this, let's open up the Hypershade editor by clicking this button up here. And in the Hypershade editor, you can click tab to add a node. So the first node we want to do called the state float node. Um, and we want to set this variable value to RL. This will get the distance from the shading point to our camera. And then we want to go and do an AI multiply. Once again, by clicking tab to bring up the search menu. Here, we want to connect this out value over here, like this. And then we want to take this multiply. We're going to do an AI add. Connect this like this. I'm going to set this to 1 because we want to add a value of 1. And then we want to take the reciprocal. So AI reciprocal. And then we're going to take this out R value into here. So let go at this section. It'll pop this up. Click other. Then find edge width scale. So this will connect the R to the edge width scale. And then if we look at what this looks like, it'll look like this. And we can adjust the AI multiply. So here, if we go to the AI multiply node here, on the side up here, so here, if I decrease this, then I can adjust the fall off function. So don't put it at all the way 0, or else this is like as if we did nothing. You still have the same issue. But you can see how the farther away the object is, the less thick the line is. You can make the fall off higher by increasing this value. If you notice here, how if I zoom really close in, since the fall off is so high, the edge width are different. What this is doing is it's essentially thinking this function over here. So we have x, which is the distance from our camera. We multiply it by value a plus 1 and then take the reciprocal. You can see how if I just set a to 1, or a equals 1, as the distance from the camera increases, the edge width also decreases. Well, I can use a as a sliding value, so if a is 0, then the width stays the same. Otherwise, if it's if it's like higher, I can change how fast the drop off value is. So that's essentially what this is doing here. We're taking the RL, which is the distance to the camera, we're multiplying it by a, and so this slider right here is a. And then we are adding it to the value 1, which is pure white. And then we're going to take the reciprocal, and then we're going to plug that into the edge width scale. Yep, I hope that helps. If you have any questions, just let me know.